What we're going to take a look at now is working with formulas, and a formula is just an equation that somebody uses a lot to convert one or more inputs into an output. And then an algebraic expression like this one here, this is a multiplication. The parts of the multiplication are the factors, and the result, the whole thing, is called the product. So what we have here is a product, and what we're asked to do is identify the individual factors. So the individual factors are the 2, the a, and the x. Those are the quantities being multiplied together. In number 2 here, the factors are the 5, the d, the e, and the f, right? Those are the individual parts being multiplied together. Now, in number 3 here, we're looking at 25 m cubed n squared. If we actually expanded that all out, it would look like this. 25 m cubed is really m, n squared is n. And now if we write the individual factors, we'll have the 25, right? The 25 right from here. And then we'll have an m, another m, and another m. So we're going to have an m, that first one, m, the middle one, m, the third one, and then we'll have the first n and the second n. Now, in number 4, what we're supposed to do is write the numerical coefficient of the given term. So here's our given term. Now, a coefficient is just a multiplier, and what we're looking for is the numerical multiplier, so we want the 18 here. So 18 is the coefficient of y squared. That is the numerical coefficient of y squared. Here in number 5, the numerical coefficient is the -2, right? That is the numerical multiplier of this term. So we are going to write just -2 here. Now, in this little group of problems here, what we're going to do is identify the coefficient of the factor that is listed second. So suppose in number 6, we list the y second. Now, all we have to do is just think about, identify the y and think about all the multipliers. What's multiplying the y? Well, what multiplies y here is 5x. So according to our book's definition, the coefficient of y is 5x. I'll write it over here. Now what if we rewrote it? Let's just write it again and write 5xy, and now we write an x. So what would be the coefficient of x? So look at the x and see what's multiplying it. What's multiplying the x is the 5 and the y. So I would say that this coefficient of x then would be 5y. And if we wrote it again, 5xy, and then wrote the 5, the coefficient of 5, well, just ask yourself, what's multiplying the 5? The xy. So identify what you're looking for, and whatever's left over, that's going to be its coefficient. So the coefficient of 5 is xy. In problem number 7 here, let's take a look at this expression, and why don't we write the coefficient of c? So we'll get the coefficient of c by looking at c and then identifying everything that's multiplying it. So here's what's left over. There's the c. What's left? What's left is this multiplier, which is -35ab. Let's write it again. How about if we have -35abc, and this time we ask for the coefficient of ab. So now we just identify the ab, and we ask ourselves, what's multiplying the ab? Well, whatever's left over, the -35 and the c. So the coefficient of ab is going to be -35c. Now, here's what we want to do. We're going to start translating English statements into mathematical symbolic statements. And oftentimes, most often, all you have to do is read it and then write what you read. So what we'll have here is this. The length, all right, now that's L, so let's write the L. The length, and then we come to this. The length of a picture frame is, all right, now is an equal sign. And then we come to this. 8 times the width. So 8 times the width, well, the width is W, so 8 times the width is going to be 8W. Now, number 9 is pretty much the same as number 8, but what's being shown here is that you don't have to let L be the length. We could let length be any letter at all we want. So in this case, maybe we're going to let it be H, like it's the height of something. And then, so what we're saying here is, in a given length, the number of inches in that length is equal to, so 39.4 times the number of meters. All right, and m may be for meters. So let's translate this. So we're going to have the length, which is h, equals 39.4 times, so multiplication, the number of meters. So h equals 39.4 m. In this next group of problems, we're actually going to start using formulas. We're going to be given a formula and some numbers for the variables, and we're going to substitute in and compute. So as our first problem here, let's take a look at this. This is called the distance formula. It says the distance is equal to the rate times time. So the distance that you travel is equal to your speed times the number of hours, t's typically given in hours, that you do the traveling. So what we want to do in this problem is we want to find d, how far do we travel when we're traveling at this rate, 5,000 miles per hour, for, 45 minutes. Now we want t to be in hours, so 45 minutes. Let's rewrite that. 45 minutes, do you know that that's 3/4 of an hour? Okay, that's 3/4 of an hour. So when we substitute in, we're going to get d equals 5,000 miles per hour times 3/4 of an hour. Now maybe first up you can see that the hours are going to cancel here, and then we're going to be left with d equaling 5,000 miles times 3/4. So the way I'm going to handle this is I'm going to multiply the 5,000 times the 3 and then divide the whole thing by 4. So I'm going to do it this way. d is going to be the 5,000 miles times 3 and then divide that result by 4. So d is equal to 5,000 times 3 is 15,000 miles divided by 4. And when I made that division on my calculator, I got 3750, and we still have the miles. Right, here in problem 11, we're given that a technician measures the current in some electrical circuit to be this number right here, negative 1.9 amps, and the resistance to be 11 ohms. And what we want to do is find the voltage. Now, we need to know the relationship between current and resistance and voltage. Now, in the book, there is a relationship here. I think it's given on page 75. And looking at that, I see this. It's number 6 there. I see that the voltage is equal to I times R, where I is the current. All right, so what we have here is this is the voltage. This is the current. And this is the resistance. So I found that in the book on page 75. There's a list of formulas there that you're going to find useful. Now, when I put these numbers in, I'm going to get V equals I, which is negative 1.9 A, right, for amps, remember that, times the 11 ohms, and there's that omega for ohms. So then when we multiply, we get the voltage is, now, negative 1.9 times 11, all right, that turns out to be 20.9, negative 20.9, and then amp ohms. Now, as it turns out, this amp ohm, this is what a volt is. So a volt is measured in amp ohms. So what we're going to have is, this looks a little strange. You know what? I'm going to write this. The voltage is equal to negative 20.9 volts. This is voltage. This is volts. Problem 12, we're given the formula here. We don't have to look it up. We're given the formula that S is equal to 1/2 the value, 1/2 times A times T squared. And we're also given here that A is 25 feet per square second, per second. That's an acceleration. And the T is equal to 12 seconds. So let's substitute. We're going to get S equals 1/2 times A, and A we're given as 25 feet per second squared times 12 seconds. So just so that I can see what's happening more clearly, I'm going to write all the numbers together. I'll have 1/2 times 25 times 12, and then I'm going to have this, feet over seconds squared times seconds. Now, when I make this multiplication, I'm going to do the 25 and the 12 first. So I'm going to get S equals 1/2 times 25 twelfths is 300 feet over seconds squared times seconds. And then right here, 1/2 of 300, that's 175. So S is 175. Now look what happens here. Look what happens with these units. This seconds will cancel with one of those. Right? We've got 2 on the bottom here, 2 of these SECs on the bottom and 1 on the top. The 1 on the top will cancel with one of those on the bottom, leaving what? Feet over second. So we're going to get feet over second. And that turns out to be a speed. So what we're saying here is that the speed is 175 feet per second. Problem 13 deals with the number of bolts in a shipment. And we're given this formula here, that the number of bolts in a shipment is 36 times lowercase n, small n, where capital N is the number of total bolts in the shipment, and 36 is the number of bolts in a box, and small n is the number of boxes, right? So if you had just one box and there's 36 bolts in it, the total number of bolts that you would have would be 36 times 1. If you had 2 boxes and 36 bolts per box, you would have 36 times 2. That would be capital N. If you had 10 boxes, you'd be 36 times 10. That would be the total number. So the formula seems reasonable. Let's compute. So let's find the number of bolts in the entire shipment when the number of boxes is 180. So putting into our formula, I'll write the formula first, 36n, and then I'll substitute. I think it's always a good idea to start with the formula and then just start substituting in. It's a good map. So we're going to get n, the total number of bolts in the shipment is 36 times n, small n, which is the number of boxes, and we have 180 of those. So this is a calculator problem perhaps. So 36 times 180, I'm getting 6480 out of that. So n is equal to 6480. But let's just be careful. What we want to do is we want to find n. So we found n. So the question is, how many bolts in this total shipment? So the way I'm going to write the answer is this. How many bolts, total bolts in the shipment? 6480. Right? I'm going to say that 6,480 bolts. I'm not going to say that how many bolts are in the shipment. I'm not going to say n equals. I'm just going to say the number that it is.